All right, present value annuities. The formula I'm just going to write down quickly. It's different from this morning's one. So P is equal to, I'll explain the difference between the two just now. I just want to make sure I have the correct formula here. Okay. X1 minus, okay, yeah, it's this one. All right, so it's similar to the future value one, but obviously not exactly the same. So with the future value one, you also start with x, but then you have your bracket to the power of positive n minus 1. This one is 1 minus the bracket to the power of negative n. All right, I printed the notes that are on Classroom, and Mrs. Smith actually did do the derivation quite nicely, so you can go take a look there if you want. You want to know where these formulas come from, but it's not examinable. Okay, you don't have to be able to do it. Now, guys, again, this formula works for when payments are made at the end of each period. All right, so this is payments made at end of each period. So what do you think we're going to have to do if the payments are made at the beginning of each period? We're just going to have to, yeah, we're just going to have to put one interest bracket next to the X, just like we did with the other formula. All right. Now, guys, a future value annuity, if you think of the examples that we did this morning, it was where you're saving up to have a certain amount in the future. All right. So with your pension fund, for example, we calculated how much you are going to have after, I think it was 25 years, that example that we did. The other one was someone wanting to open, Sam wanting to open a business. All right. So needing an amount of money after, was it 6 years? That was the one with the 12 payments. All right. So future value. The other one was the bus that they had to replace after 5 years. Yes, 5 years. So they needed, or they are going to need 900,000 Rand in the future. All right. So we used the future value formula. All right. Present value annuities. This actually has to do with things like loans, bond repayments, where you get an amount of money at present. All right. The loan amount that you are taking out, you're taking out a loan for 1 million Rand, whatever. That is the present value of the loan. Now you have to pay it back in equal installments. Okay. So future value annuities, that's actually when you're saving up. Present value annuities is when you are paying something back. All right. So that's an easy way of remembering the difference. So this is with loans or bond repayments, for example. That's a real world example. Get ready. It's not all it's cracked up. All right. So present value. So that is any amount of the loan is going to be the present value. Okay. I'm just looking at these notes quickly. An annuity, again, we're going to have equal payments. All right. That is what an annuity is. So it is just like a normal loan, right? You have to actually pay an amount back every month or every whatever. It is usually monthly. So just like this morning, we're just going to do some examples where we apply this formula. And then these are the only notes that are on Classroom. So I'm thinking maybe this is as far as you're supposed to get full marks. I will just double check. It does go further, yeah, but there's nothing on Classroom, so no other notes. So I think this is maybe, yeah, what we're supposed to get up to. Yeah. So finance is the last section for the whole year. Yes. No, we're going to have to do more afterwards. And are we going to have a holiday? Who knows? It's not me. Don't say man, please, to me. I have no say in it. Just say it to Miss Wacheka. You must say man, please. I just work here. I have no say. Well, we haven't finished the syllabus yet. As you can see, we're still busy. Yes. We are close, yes. What if?
Just say we're done.
Imagine if we have one of these extra lessons and then we don't get on.
Yeah, I know that would be terrible.
I think they just were doing online classes for that week.
No, we did so many online classes and like no holiday. I'm sorry. So me. You too, I will.
Oh, there's actually a B and C that I don't want to do yet. Sorry. So it's actually just A. My apologies. I just saw now B. I don't want to go into that yet. Outstanding balance. No, we'll leave that for another day. Sorry, I didn't realize that when I was copying it down now. Okay, so Simon wishes to purchase a car for 80,000 Rand. If he borrows the money at an interest rate of 8.5% per annum compounded monthly, calculate the monthly installment. So that's X, right? That we need to find now. If the loan is to be paid back over 5 years. Now, guys, they're not making any, they're not saying anything about when payments are made. Then we have to assume that they're made at the end of each month. All right. So if they made at the beginning of the time period, they will have to say that because that's like the different type of question. Okay, so our assumption is always that it's paid at the end. All right. And it was actually the case for me when I bought my car. I made my first payment at the end of the first month, not straight away. Okay, so 80,000, yeah. My car was 80,000, but that was also 9 years ago. So all right, and was secondhand as well. All right, so this 80,000 Rand, he's borrowing the money right now so that he can buy the car. So do we understand that this is the present value? All right, he's not saving up to have 80,000 in 2 years' time. If that was the case, we would use the future value formula. All right, so this is a loan. So this amount is our P value, our present value, the amount that he's taking out as a loan. So we're going to use the present value formula again because I'm solving for X. I would like to write it on the left-hand side. Okay, that's just my personal preference. So I'm going to write this formula down. And now, guys, we mustn't get confused. This formula is different from the one we used this morning, but both of these are on the formula sheet. Okay, the future value formula is on there and the present value. So now we're just going to sub all of our values in. 1 minus bracket 1 plus the interest rate that they gave us was 8.5% compounded monthly. So that's 8.5 over 1200. And now, guys, do we notice that our exponent is negative? Okay, so we have to say negative. If it is 5 years and it's monthly, you can obviously write 60 straight away, yes, but you can also just write 5 times 12, that's perfectly fine, over the interest rate again, which is 8.5 over 1200. And that is equal to the present value, which is 80,000. Okay, solve for x there, please. Get your calculators out, do some punching. So you're going to times and then divide, all right? All right, do we have an answer there? Oh, sorry, I nearly dropped my page. So x is equal to, let me just quickly check what my answer is. 1641, 32. Okay, there we go. 1641, 32. All right, are we fine with that? Now I want us just to do an example where we have to solve for n. I think you are all actually able to do that already because you work with logs quite a lot in AP, but let's just have one in our book so that we know that it is also a thing. Now I see that Mrs. Smith put it in the revision note, which I don't think we did it last year, hey? So I don't know.
They did an example of finance.
At the beginning of the year. Oh, earlier in the year. Okay. Okay. So that's probably what she means by that. Okay, so guys, this is now actually a new note. That's basically it for present value annuities. You just need to be able to use the formula, but sometimes you might have to solve for n, and I'm going to show you now, okay, how that would work. So, determining the time period using logs. We can actually just say determining the time period. We don't have to say using logs. Yeah, see the example that they have here is just a normal compound interest one. So we'll just do it and then I'll just give you one of those, the present value ones or future value to quickly do. So an investment of 25,000 Rand grows to an amount of, and then it is 55,267,04. Okay, you can do that on your own. Guys, in this case, it's just one investment that grew to an amount of 55,000. So are you going to use future value or present value? Is this multiple payments made at equal intervals? No, it's just one investment. So you're just going to use the compound interest formula, right? A equals P bracket 1 plus I to the power of N, and then you're going to solve for N. But now, of course, N is the exponent, so it's not as easy. Yeah, you're going to have to use log. So see if you can remember how to do that. Okay, there you go. That's what I got. 7. Right? So I just wrote my formula down. Then I just subbed everything in. So A is 55,000, P is 25,000, and then this is fine if you wrote it as 12 over 100. Okay, I just wrote it in decimal form. Then I also swapped sides. Sorry, because then I realized my N must be on this side, but it's fine. You could have left it there. And I also simplified my bracket. 1 plus 0, 12 would be 1, 12, right? Or you could have just left it as 1 plus 12 over 100. Nothing wrong with that, to the power of N. And then this 2,210 was 55,000 divided by 25,000. All right, then I got that. Obviously, I'm not rounding off here. Remember, you can only round off in your final answer, but you are working on the calculator. So now if you're solving for N, remember the exponent becomes the subject. The base of the exponent becomes the base of the log. Okay, we've practiced this a lot in AP. And then the other number just goes after the log. You type that in and you get 7. It's 7 comma this. It's a bunch of zeros. All right, but that obviously we can just round off to 7 years. Okay, is that fine? Now, guys, I'm afraid we have to do balance outstanding. It's actually not that bad. I found my note. I just couldn't find my note earlier. Okay, so balance outstanding on a loan. We need to be able to, at any point, if they tell us, okay, you have this loan that you took out and you've been making these payments after 3 years, how much do you still owe on the loan? All right, so we need to be able to actually calculate at any point in time how much money is still outstanding on the loan. So that is the new note. I'm just going to carry on underneath. I'll show you what it is. I'm going to write down the two methods. So I think I'll fit the two methods in underneath this example. And then we're going to do some examples. Okay.
I'm going to do an example with the new one.
Oh, I did say I'm going to give you one. Hey.
Yeah.
Yeah. Sorry. Thank you for reminding me. Let me just find out an exercise. So there's actually a whole exercise on questions like these in the textbook. Let me just find it quickly. 112. Okay, yeah, let's quickly do, I'll put it on the board, but I'm just going to write here, exercise 4.7, page 113. And I want you guys just to do number, let's see. All of these are actually just one amount. Oh, wait, there's one. No, it's not. Okay, so none of these actually have that formula. Let me just quickly check. Into an account. Let's see. Oh, man. Okay, I'll give you this one because it is similar, but it's not entirely the same. So number 3. Oh, number 4. Let's do number 4. Okay, so just write that down, guys, and then I'll put the question on the board quickly and you can just do it. So number 4 of this exercise. And then we'll do balance outstanding. Okay, there is number 4. Can you all read that? Right, do that one quickly. Treble is just triple, hey? Isn't it?
Yeah.
Making me doubt what I know. Yeah, I think it's just triple, yes.
Sorry, so you say number 4.
Yeah. Hmm? Guys, it's only Tuesday and we're all so confused already. 1 plus. And guys, we are just using 365 as a number of days in a year, okay? We are ignoring the fact that leap years are a thing. we'll talk about that now. Mhm.
So you know how like a year, like single 100 month.
Yeah.
What would we do daily?
36500. So 365 and 2 zeros.
Oh, it would be bigger. Okay. Thank you.
No problem.
I said 1/365.
Yeah, you are basically taking 14/100, dividing by 365.
Oh, okay.
That's what it actually comes from now. Okay, do we have some form of an answer? I think the years and days is what's getting us. So let's quickly look. So that is what I got. And I said just approximately, because it's not exactly, but we can talk about that now. I just want to show you guys the working. All right. I think we all were able to get to this line. All right. The log. So what I did just quickly, it's this. So I just used 3x and x, but you could have used 300 and 100 or 30 and 10. All right. Whatever it is, as long as your p value is your p and your a value, they're in the ratio of 1 to 3. All right. Because they said that your original amount must triple. Okay, now guys, what's going to happen if you do 3x divided by x? The x's are going to cancel out. All right, so whatever these two are, if you take that one, you take your a value divided by your p value, you're supposed to get 3, right? Because your final amount is supposed to be triple your original amount. Okay, so are we fine with this? Yes.
Was the interest rate 40?
I-
Sorry, I just didn't.
Yes.
Okay.
I got like a, oh no, yes, it was. Okay. Yes, it was 14. Okay, now what I did was, again, I just swapped sides. So inside this bracket, you see that's what I calculated, and it actually comes up as that. All right, but I didn't want to write that down. So I just wrote down 1,003 and then some dots, because obviously we're not rounding that off. So it's that to the power of n is equal to 3. Now we do log, so we say that n, so the exponent becomes a subject, that is equal to log. The base of the exponent becomes the base of the log, so we do our log button. Now we're just going to press answer there, and then the other number goes after the log, so we get 3. Now we get this, but guys, n is number of days now, right? Because it's compounded daily. So 2,865 days, basically. Can I say that it's 2,864 days? Would it have reached that amount after 2,864 days? No, all right? It's within that day that it triples. So you would have to round up. So guys, you could write that down. You could write down 2,865 days and then convert it back to years. All right, but they said our answer must be in years and days. So I just said divided by 365. All right, so that's 7. Now this portion here is the number of days, all right, or the part of the year that's over 7. So I minus 7 from that so that I could see the remaining part. And now what you're going to do to get that in terms of days is you're going to multiply it by 365. If they wanted months, you would multiply it by 12. If they wanted quarters, you would multiply it by 4. So times 365, and then that gives you 309.7, which you have to then round up to 310 days. Okay. So I think it's actually good that we did this example now, so you could see that we haven't really done converting the time periods. Okay, any questions, guys? All right, balance outstanding on a loan. That is the new heading. Balance outstanding on a loan. Like silence, and then just every now and then someone sighs. You guys all done writing down the first one, I'm sure? Okay, I'm just going to write the example down and then we'll discuss it, because I'm sure by then everyone will have written down both methods. Oh, it's again Sam. Sam is doing a lot of things in terms of finance. Now you're buying a house. Okay, so Sam buys a house at a cost of 850,000 Rand. What are you talking about? Hey, what's going on? You just realized that. Grace.
Is that normal, right?
I'll be ready to map to anything.
I don't want to make soap. I don't want to use my kitchen for
Don't laugh. I'm in humanities, guys. Where now? Oh yeah, using this formula.
I somehow like read like if they're regular proportional, that's fine, or like what's the detail?
Oh. It's fine. I understand. Yeah, we could actually. Is it? What's his music?
I regret it not bringing my headphones. Only days.
Oh, bird noises. Interesting. Isn't he supposed to be coming back soon?
I think so. But it is quite interesting because like someone asked me someone else is connected to the
Yeah. Technology, hey? What's the phone man?
and then on the wait, so this space is like big. Just to like see what it looks like. And then just they were like, hi Adrian, and then they let me.
Did anyone see in the summary today that's like a Mr. It was like Roberto Luberto.
Yeah, well, that's strange. Okay, guys, if you haven't copied down the example yet, that's fine. Let's just quickly talk about these two methods. I don't know if it makes sense already. Hopefully, I don't have to explain too much. All right, but balance outstanding on a loan, the first method, and I'm guessing that most of you will prefer this method because it is shorter than the other one, but it is sometimes also more difficult than the other one. And you are more prone to making mistakes, I think, than the other one, but maybe you guys will be fine. So that is where you find the present value of the payments that are still supposed to be made. All right. So if it's fine. I'm not going to use an example. We'll do it now in the example. We'll do the two methods so that you can see how they work differently. All right. But for the first method, you have to do an extra calculation. They're not going to tell you how many payments are remaining. All right. They're going to say to you, find the balance outstanding after 3 years. And then you must calculate how many payments are remaining. And that then becomes your exponent. All right. The other method, which actually makes a lot of sense to me more than the first, but I think it's probably because my teacher in high school just taught me the second method. So I've just been prone to using that one. It's where you kind of approach it in two different ways and you find the difference. So you almost look at the loan as if it's a loan on its own, right? Remember the loans that we did in grade 9, where you just borrow an amount of money and after however many years you have to pay it back, all right? So you look at the loan as if it's that kind of thing. So say they say after 3 years, you calculate how much money you would have to pay back after 3 years. And that is what this first part of the formula would be, all right? But then you minus, because remember with these annuities, you are making payments all the way through. So you won't still owe that amount. You won't still owe this amount. You actually have to then minus all the payments plus the interest on those payments that you have already made, right? So it's almost like you're looking at a loan on its own, and then you're thinking of all the payments that you're making. It's almost like you're making an investment in a sense, all right? And then the investment, the money that you've put away by making those payments all the way through are then being subtracted from the loan. And that is in the balance that you're left with. Okay, the nice thing about this formula is that you're just using N. So if they say they want the balance after 3 years, your N is going to be after 3 years. Okay, you don't have to first calculate how many payments are remaining. I know that it seems like an easy calculation, how many payments are remaining, but later on, probably after mocks only, we're going to work with loans where you don't have whole number of payments left, whole numbers of payments left. You might have like 1.7 payments left, all right, stuff like that. So we're going to talk about the final payment on a loan that is often not the same as the other payments, all right? So later on, this method can become a bit complicated. But for now, it's fine. We're going to practice both of them, and then you choose the one that works for you, and you can stick to that one. All right, they're never going to tell you which method you have to use. You can decide. Okay, just quickly finish copying that down if you haven't yet. First, we're going to calculate the monthly repayments, and then we're going to find the balance outstanding. If you've done copying this down, you can do this calculation so long. All right, Sam buys a house at a cost of 850,000 Rand. Sorry, he pays. Yeah, he pays 10% in cash. All right, so that is the deposit that you're obviously going to have to calculate. It's easy. It's the 85,000 Rand. And the balance is paid using a bank loan. So the 850,000 minus the 85,000, that is going to be the present value. That's what he's going to take out as a loan. All right, so that is your P value. The 850 minus 85. Interest is charged. They're telling you there's a interest rate. Determine the monthly repayments if the loan is repaid over 25 years. Okay, so you're solving for X there. Do it on your own, please. Present value.
So, which do you recommend?
Oh, for the balance.
Yeah.
I've just always used the second one because I feel like it requires less thinking. But yeah, you'll get the same answer for both. Right, do we have an answer there? Show you what I got. 6419,85. Usually I hear yes, now I'm hearing nothing. Yes.
So how can you make it? Oh.
Well, I suppose the fact that they're asking for the monthly repayments in the question.
Oh, yeah.
Yes, I would think so. Okay, obviously this you could have just done the actual value of that. I just wrote it separately and then I did the calculation. Does it make sense to you guys why we use the present value formula? Right, because it is a loan that he's taking out. So he is immediately getting that amount after he's paid the deposit. And he's not actually getting it, but he's getting the house. So getting the value of that money. I'm just waiting for everyone to finish copying that down and then we'll just find the balance. After 10 years, if you want to write that down, number 2, determine the balance owing on this loan after 10 years. Then we'll just practice both methods and then we're done. Are there any questions on this, guys? Will the balance always be equal to the P value? You mean this balance, yes, but not the balance owing. Yeah, it's 2 different things. They just mean the amount that he's taking out as a loan. That balance is what they're referring to here. Yes.
When we're going between 2 different questions based on the answer of a previous one, like finding the monthly installment and using that, should we store the value of the monthly installment?
No. So if it was a final answer to a question, then you can work with the rounded value. But if you store it, they won't mark your answers wrong. But now because of that, because we're going to work with that rounded value from number 1, you will see that using method 1 and method 2, our answers are going to differ slightly. But it's because our X value is a rounded off value. Okay, so we're determining the balance owing on the loan after 10 years. So I'm just going to write method 1 here. And then we're going to try method 2 as well. Okay, so for method 1, that is where we use the present value, or we find the present value of the payments that are remaining. All right, so I'm just going to write that formula down that we put on the previous page. So it's the present value formula, but now it's to the power of negative m. I suppose you can use any letter there, just as long as it's not n. Right, what was the monthly payment? That's what we found in the previous question. So we're going to use 6419,85. We have our interest rate, which is the same one that they gave us. Now this was monthly. All right, so I'm going to times by 12, but how many years are left? If 10 years have passed, this is a 25-year loan. How many years are left? 15. All right, so that is how you would find the number of payments that are left. You can obviously write that as an actual value, but it would be that 15, okay, because there are 15 years left. Over I. And then you just type that into the calculator and you get your answer. Okay, so you use the present value formula but that is then for the payments that are left to still be made. And this answer is quite upsetting if we remember that this loan was what, 700 and something thousand. 95490. After 10 years of paying 6,400 Rand every month, he still owes that much money. That is what happens in real life. Yep. Yeah, it doesn't, but some people can't afford to buy things if not on credit, unfortunately. Okay, that's method 1. Method 2. So this is now where we do our P bracket 1 plus I to the power of N, and then we minus the future value. Let me just check, is this the right formula? Yes. Of the payments that we have already made. So we see what would this loan have been worth after, what is it, 10 years? And then we minus the value of all the payments that we've made for 10 years. And the difference there that we'll get then is the balance. What was this again? It was 850 minus 85, which is 765. Can't even do that in my head. Wow. Thank you. All right, 1 plus 9 over 1200. And now our N is after how many years? After 10 years. So that's what we use. So we're going to do 10 times 12. All right, so that's what I meant when I said that this method doesn't require like extra thinking. We don't have to think, okay, how many years are still left? We just say if they're asking for after 10 years, then it's 10 years that we're using there. So that is what the loan would be worth after 10 years, or what we would have to pay back after 10 years. But now we have already been making some payments. So we minus the future value of all of those payments. And that will then give us the balance. So it's 120 is our exponent there. No, they're not. The separate parts are, so the present value formula is on the formula sheet, and this one is, and that one is, but putting them together into the balance that you have to do on your own.
Working out how much the loan is worth.
Yeah, if you weren't making any payments along the way. If it was just a loan, you just took out this money and you have to pay it back after 10 years. But that's why we minus, because we've been making payments every month. So this is almost like an annuity, like an investment fund that we've been setting up in a sense. So then we take that out of what the loan is.
Yeah.
Okay. And now if you type this into the calculator, it's okay if you didn't. I don't hear lots of keys going, but it's all right. You will see that your answer is similar but slightly different. And the reason for that is because we worked with a rounded off answer for X. Okay, so if you work with the actual value for X, if you stored it in the calculator, we would have gotten the same answer for both methods, but it's fine. On the memos, they have 2 solutions. All right, they have a solution using method 1 and a solution using method 2. So you won't be penalized based on which one you use. Both are fine.
Check the outstanding balance, and this is one thing that we calculate this.
What do you mean in real life?
Yeah, what would you do with it?
Surely lodge a complaint. Yeah, I don't know. All of these things are run by technology. I don't think it's a person sitting there making the calculation. So it would have to be like an error with the system or something. That's okay. Okay. Oh gosh, what a nightmare. I can't use Excel to save my life. Okay, guys, you are going to have to practice this, but I'm not going to tell you what you're supposed to do now. All right. tomorrow, when do I see you? Let's take tomorrow to finish off core, okay? So tomorrow we're gonna just practice for the hour. We're gonna do finance. We're gonna make sure that we know what's going on with similarity and proportion and with probability. And then we're done with core until mocks, I'm guessing, all right? So after that, we'll just do AP unless they tell me I must teach you something else before mocks, and then we'll do that as well. All right, so core tomorrow and then AP. Cool, thank you guys. Have a lovely late afternoon / evening.
No, bio. Bio, I know, right?